Hi, I'm John.
And I'm Dave.
So in the last video, we learned how to get fancy with sentences that involve multiple quantifiers and even multiple quantifiers of mixed type, so both existential and universal. In this video, we're going to provide some advice on how to translate English sentences into FOL sentences that have these multiple quantifiers.
So as the complexity of the sentences increases, it can be tricky to keep track of the relationships between the different quantifiers in the sentences and their variables. If you follow the techniques that we present here, you should quickly become as fluent in translation between English and FOL as John himself is.
My goodness. So the first strategy that we're going to suggest is actually a very useful one when translating English sentences into FOL, but it's actually applicable to all complex problems. And that is to break a complex problem into smaller pieces and tackle the problem in a step-by-step fashion.
The divide and conquer strategy.
Right.
We alluded to this strategy when applied to fold translation in the previous video, when we suggested you could read a sentence like this: for all x, tet x implies there exists y, cube y and front of yx, as saying, every tet has some property. What property? Well, the property that there is a cube in front of it. We're explicitly reading the sentence as the Aristotelian form of the main sentence, every tetrahedron has some property, and then reading the embedded sentence separately.
And similarly, when we're asked to translate an English sentence, we can translate the outer skeleton of the sentence into FOL and leave placeholders that need to be filled in later. And then once we're secure in the correctness of the outer skeleton that we've translated, we can move inward and flesh out the translation until no placeholders are left.
So this is easier to do than to describe. So let's look at an example. So our example sentence is, every cube is to the left of a tetrahedron. Now, despite the fact that this sentence contains two quantified expressions, every cube and a tetrahedron, you might immediately recognize this as a formula of the form, every cube has some property. If you do, then you know how to translate this into FOL before we even worry about what the other property is. So however we translate this expression, it's going to be something of the form, for all x, cube x implies, and then whatever the translation of x is to the left of a tetrahedron turns out to be. So we've just left a placeholder here in the expression. This is what we mean by having a skeleton of the translation.
So now the expression here on the right, x is to the left of a tetrahedron, is a little confusing because of the x. But we do know how to translate the sentence, b is to the left of a tetrahedron. This is just an Aristotelian sentence. There's an object which is both a tetrahedron and which b is to the left of.
So now we can put these pieces together. We want to use the expression b is to the left of a tetrahedron and replace the placeholder x is to the left of a tetrahedron with that expression, but we have to remember to replace the b in the b is to the left of a tetrahedron with the x from the larger sentence. So we obtain the sentence, for all x, cube of x implies there exists a y such that y is a tetrahedron and x is to the left of y.
And that's how we translate every cube is to the left of the tetrahedron. Okay, now we can actually show how the strategy works with an even more complex sentence. So let's try that. Okay, so this sentence is of a negated existential form, which I chose to translate as, there's no cube which has some property, x is to the right of a tet, and which also has some other property, x is to the left of a dodec. So the first property is being to the right of a tetrahedron. The second is being to the left of a dodecahedron.
So each of these properties are relatively straightforward to translate when you recognize them as some P is Q sentences. So x is to the right of a tetrahedron, some object is to the right of a tetrahedron. So let's translate x is to the right of a tet. That's going to be the translation of our placeholder. That's going to be exists y, tet y, and right of xy. So there's some object, which is a tetrahedron, and that x is to the right of. The second property, x is to the left of a dodec, is very similar. There's some object which is a dodec, and x is to the left of it. So again, this is translated as there exists z, dodec z, and left of x, z.
Okay, and now with all of these pieces in hand, we can assemble them into the resulting FOL sentence, which is pretty impressive to look at indeed. So there we have it, and that is indeed an impressive sentence.